All right, 14 is a problem in which you can still solve this the same way as any rational equation. If you think of the methods that I talked about, what I recommended is you multiply everything by the LCD of all the parts, all the fractions involved. So we need to multiply by a 5x plus 4 as well as a 3. So here's my LCD, and just multiply this to all fractions in the equation. Okay, notice what happens when I multiply by this first fraction. I'm just left with the 3, that 5x plus 4's cancel, times the original expression, 5x minus 4 in the numerator. And then that equals here when I distribute my LCD, the 3's cancel, so I'm left with 2 times 5x plus 4. Now, you may have heard this as you just cross multiply, right? This is called a proportion. When you have two ratios set equal to each other, you can solve it by just cross multiplying. And you can see that that's exactly what I did here, right? That's in effect what we did when we distributed this. So you don't need to necessarily think of it as a different method. It's the same thing that we talked about for all of these. And now it's just a matter of distributing through and solving for x. So you get a 15x minus 12. Distribute the 2 is equal to 10x plus 8. Move all your variable terms to one side. So if we subtract 10x from both sides, we're left with 5x. Add 12 to both sides, we get 20. And we're left with x equals 4. Now, you do want to test it. You have a variable in the denominator. So what's the one thing that you know x could never be, for sure? -4/5. So in this particular case, if you don't have time to plug it in completely and test it, you should be okay. But if you notice that this was that number, -4/5, you could see that it's a no solution as it is. But this one, if you have time and can test it, 5 times 2 is 20. 20 minus 4 is 16. 5 times 4 is 20. Minus 4 is 16. 5 times 4 is 20 plus 4 is 24. Does this reduce down to 2/3? 8 goes into 16, oops, twice. 8 goes into 24 3 times. So yes, it does. Check.